What is integration? So, to understand this deeply, let us consider an example. So, let us say that a man is starting his journey at around 12 p.m. and ends the journey by reaching the destination at around 4 p.m. So, assume that he travels at the speed of 50 km per hour. Okay. Now, the question that we are going to raise here is, what is the distance traveled by him between 1 p.m. and 2 p.m.? Now, we'll find out the answer as well. Now, we are going to use the formula speed equals distance by time. So, we are asked to find out the distance, and the speed is given to be 50. So, distance equals speed is 50, and between 1 p.m. to 2 p.m. it's going to be 1 hour. So, practically, the man has traveled for 50 kilometers. All right. So, he has traveled for 50 kilometers, is the answer. So, now we are going to try to solve this problem in a different manner. So, they have given us the velocity. All right. Velocity is given to be 50. Now, velocity can be written as a function. We know very well that velocity is the first derivative of your distance function. So, it is technically ds dt, right? Now, since it is the first derivative of the distance function and we are asked to find the distance traveled by him in 1 hour, we can get help from the definition that velocity is the first derivative of your displacement function. So what I can do is I can probably write ds dt is equal to 50, and from here I can try to find out your distance as the function. So now the question that we have to ask ourselves is, what could be the value of s of t such that its first derivative has become 50? So now we know very well that your differentiation of x is 1. So similarly, your differentiation of a constant times x would be the constant again, right? So here your derivative is 50. So the function before differentiation would have been 50 times x. So I can easily state that when your first derivative is 50, the original function has to be 50 since t is the variable, so 50t. And not only this, you can also have a constant c over here, because we know very well that differentiation of your constant is 0, because 50 can be written as 50 plus 0. There is a possibility that there is a constant in the function such that when it got differentiated it has become 0. So now I have just found out your distance function, right? Now we are asked to find distance traveled between 1 p.m. and 2 p.m. So what I can do is I can simply find distance traveled by him between say 2 p.m. and 1 p.m. I can find the difference of it. So it will be 50 times 2 plus c minus 50 times 1 plus c. So your c gets cancelled and 50 times 2 is 100 minus 50 would be 50 kilometer again. So what here we have done is that we have used the definition of your differential calculus and then try to go back to the original function. So which is technically what we have done here is to find the antiderivative of the function. So we have typically found out your integration of the first derivative of your displacement function with respect to x in order to function your s of t. Alright, so this is your integration. So integration is simply to find your antiderivative of your function, right? So there is also another way to approach the problem. So this is method 1, we'll call it to be method 1, and there is also another method. So they have given us velocity to be 50, right? Now what I'm going to do is I'm going to draw a graph. We'll simply draw a graph for t and v of t. Since it is a constant function, it is easy for us to draw the graph. It is simply going to look something like this. And between 1 and 2 p.m., so we'll have 1 p.m. to be here and 2 p.m. to be over here. And what I can do now is that I can find the area below this graph between 1 and 2. And this is simply your area of your rectangle, which is length times breadth, and your length is found out to be 50 and your breadth is simply 1 over here. So I can write 50 times 1, so this should be 50 kilometer. So what we have now established is that your area under your velocity time graph is your distance function. Alright, so using velocity we just found out your displacement, and using velocity function we just found out your displacement function as well. So now we can relate both the methods. So integration is simply finding area under the graphs is what integration is all about. So I hope I gave you an different perspective for integral calculus. So this is what integral calculus is all about. It is simply finding antiderivative for a particular function. So subscribe us for more such content. Thank you.